Welcome to Unit 2. We are starting with Mission 1a, which is going to be rational and irrational numbers. So in class I told you a little story about the caveman, what type of numbers are rational and some that are irrational. So I like to think of the difference between rational and irrational numbers as rational numbers, these are our normal numbers, and irrational numbers are kind of our crazy numbers. Just like people, you can be normal, you can be crazy, but you can't be both at the exact same time. So just like us, numbers are either rational or irrational. They're one or the other. So rational numbers, we're going to start over here, are any number that can be written as a over b, where a and b are integers or counting numbers, and b cannot equal 0. So for example, 10 is not a fraction, but I can write 10 over 1. 10 divided by 1 is really 10, and that is a fraction. So any of our counting numbers, whether it's negative or positive, are also rational numbers. So if it is written as a fraction, it's rational. It could be 2 over 3. It could be 1 over 4. It could be 10 over 1. Any of those are written as a fraction. Next, decimals are rational numbers as well. If they stop, another word for this is if they end, such as 2.4. There's nothing after the 4, it ends, it stops. Or, for example, 3.125. There's nothing after the 5, so we're done. What I mean by nothing after is there's not like a ... telling you that we're looking for another number or more numbers will be coming after it. There's nothing after the 5. There's nothing after the 4. And then repeating numbers. Repeating numbers are numbers that have the line above them. For example, 1.3 repeating would mean it's 1.33333 over and over and over again. Or let's say 5.67. And the 6, 7, they both repeat. 6, 7, 6, 7, 6, 7. That's okay as long as it's repeating. And then last, our third type of number that's a rational number are the perfect squares. The square roots of our perfect squares. So what are our perfect squares? Some of you maybe remember on our multiplication table we circled 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. We circled or highlighted all of these numbers. 4 times 4 was 16, 5 times 5 was 25. You don't need to write this. And we went all the way down to the corner of our paper. So all of these numbers were our perfect squares because we knew, for example, the square root of 16 was really just, if we looked at either side, 4. So square root of 16 was 4. The square root of 36 was 6 because 6 times 6 is 36. We're looking for the same number multiplied twice to give us that. So any of our perfect squares, like the square root of 9, we know is really just 3, which is a nice rational number. So any of those perfect squares are rational. Our irrational numbers are the crazy numbers. Those are our decimals that do not repeat and there is no pattern to them. So anything, let's say 4.387 ... anything that has a ... after it tells you that it's not repeating, there's no pattern to it, it's going to go on and on and on. Okay? Doesn't matter what the number is, could be 145.67 ... It's going to go on and on and on. It's not repeating. There's no symbol like this that's repeating, and it doesn't end. Last, our irrational numbers are any of the square roots that are not perfect squares. For example, the number 10 was not on that list. It would have been somewhere else. We don't know what multiplies to get 10 if it's the same number, like 6 times 6. We know that gave us 36. We don't have the same number multiplied by itself to give us 10. It's not possible. So that, would be a non-perfect square. Anything that's not on that list, the square root of 8, the square root of 50, none of these numbers were on that list. Like 1 times 1 is 1, 2 times 2 is 4. All of these are our perfect squares. Only looking at the highlighted ones. None of these ones. Okay? Let's look down at slide 2. We have a whole bunch of numbers here, and we need to decide, are they rational or irrational? So I'm going to cross them off as I go. I'm going to start with all of the fractions. Any number that's written as a fraction, A and B are just numbers, we need to figure out what are they. Well, here, for example, 22 over 7, that's a fraction, that's rational. 22 over 7, so I'm going to cross that one off. This one's also a fraction, negative 11 over 7. That's a rational number. Any other fractions? Nope. So I'm going to go on to my decimals. Anything that ends or repeats, those are rational numbers. Well, this first one here, it repeats. That's okay. 2.62 repeating. Here, this one here, 17.564. It ends. There's nothing after the 4. 17.564. That one's rational. 50 is really 50 point nothing. So 50 is a rational number. 3, here's 3 point nothing. It ends 3.0. These are separate numbers here. Done with that one. All the rest are either square roots or dot dot dots or pi. So let's look at our square roots. Any of our square roots that are perfect squares we know are rational, so I'm going to look for those first. The square root, negative square root of 49, well, what multiplies by itself to get 49? Well, 7 times 7 is 49. So this is really just a negative 7, which is rational. If you want to write it as a square root of 49, you can. If you want to write negative 7, it's really the same thing. Anything that multiplies to get 2, well, here nothing multiplies by itself to get 2, so that's actually an irrational number, the square root of 2. It's not on our list, 1, 4, 9, 16, 25, okay? So that one's irrational. Square root of 8, well, there's nothing that multiplies by itself to get 8. 2 and 4, but that's not the same number 2 times. It's not on our list, so we know it's not rational, it's irrational. Square root of 8. 19, also not on our list. 19's not on here. Nothing multiplied by itself gives you 19. Oops, I keep going to the wrong page. Here we go. Square root of 19, that's irrational. Square root of 3, also irrational. There's no number multiplied by itself like 5 times 5 or 6 times 6 or 1 times 1 or 2 times 2. That's going to give us 3. Last couple square roots here. This one, the square root of 46. Well, 36 is on there, but not 46. We have 49, because 7 times 7 is 49, but not negative square root of 46. That's irrational. Square root of 144. This one is really 12 times 12. So our square root of 144 is just 12, so that is a rational number. It makes sense. Square root of 144 is 12. So we have a couple left. Pi is, if you did not know, really 3.14159, and it goes on and on and on. I don't know what it is. It's not going to be a rational number. It's going on and on and on. So if you write pi, great. If you write 3.14 and dot, 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 that's fine too. And then these last two here, you guys, I don't even know what numbers those are, but I'm just going to put a dot, dot, dot in this box. Anything that has a dot, dot, dot means it's going to go on and on and on. It's not ending or not repeating like rational numbers do. It's irrational. So we've classified all of our numbers. Let's take a look at the back side. It says write I for irrational or R for rational in the box below each number, and then order the numbers from least to greatest. Show any work necessary. So 5.3, it's already written here as a decimal 5.3. So I know that that is a rational number because it ends. If you're not sure, you can flip back to the front side. Anything that ends or repeats is rational, as well as any fraction. So already this one over here, I already know that that's a rational number because we can write that as a fraction, 5 1/2. If we wanted to, we will learn later this chapter how to convert that to an improper fraction. And then we have two square roots. What times what gives us 20? Well, I know 4 times 5 is 20, but that's not actually what I'm looking for. What number multiplied the same number twice would give us 20? Well, there isn't one. I know 5 times 5 is 25 over here, so that's just 5. So that's a rational number. 5 is a rational number. We could write it as a fraction, 5 over 1. But this one here, square root of 20, is an irrational number because it's not going to be on our number line. Square root of 20. Well, we have 16 and we have 25, but 20 is not on there. So it's an irrational number. But I know, like we said, 20, if we look on our list here, 20 would be between 16 and 25. So I know this is between the square root of 16 and the square root of 25, or really between 4 and 5. So I only put that there so I can help us order these numbers. So we're going to start with our least and move to our greatest. Now, this one is a little bit tricky because all of these numbers are very similar. However, this one is 5 or more, this one's 5, and this one's 5 or more. This one here is between 4 and 5. So that means it's less than 5. It's like 4 point something. So our least number is actually the square root of 20. Then we have just 5, which would be the next smallest, or the square root of 25. Then between 5.3 and 5.5, well, 5 and 1/2, you guys, is really 5.5. A half as a decimal is 0.5. So 5.3 would be smaller. And then finally, our greatest number would be 5 and 1/2. Next, same thing. We have 6 and 3/5, square root of 48, 6.2 repeating, and square root of 36. Well, any fraction and any decimal that repeats, I know are rational numbers. Decimals, fractions, those are good to go. Our square roots, we know the square root of 36, 6 times 6 is 36. So this is just 6. That's a rational number. Makes sense. Square root of 48. Well, I can't think of anything that multiplies to get 48 that is the same exact number. But I know 7 times 7 is 49. So I know it's a little bit smaller than 7. However, it wasn't on our list, so it's an irrational number. We said it was really close to square root of 49, so it's got to be less than 7. It's between the square root of 36 and the square root of 49 on our multiplication table, only looking at the highlighted numbers there. So if we put these in order from least to greatest, all of these are at least 6. It's between 6 and 7, except for this last one is exactly 6. So that's going to be our least, the square root of 36. Then, between the next two, we know this one here, the square root of 48, oopsies, didn't mean to cross that off. The square root of 48 is really close to 49. So I know this one is really close to 7 because it's close to the square root of 49. So that one is actually going to be our greatest number way over here, square root of 48. And we have to figure out what order do these two go in. 6.2 and 6 and 3/5. So I know we're going to get to equivalent fractions later, but if I take 3/5, and you could just plug 3 divided by 5 into a calculator, or if I multiply that fraction by 2, it's really the same fraction, it's just written as bigger numbers. It's 6/10, or 6/10 as a decimal would be 0.6. We will also get to converting that later. If I were you for right now, I would just plug 3 divided by 5 into the calculator, and it would get 0.6. So this is 6.6. Over here, this is 6.2 repeating. Well, 6.2 is smaller than 6.6, or 6 and 3/5, however you want to write that. Alright, I would like you to try this last one on your own, and then click play to see if you got it right.